All right, hello everybody. Happy Tuesday. Welcome back from our break. Sorry that I can't be here. I have an appointment today that I couldn't miss, but you get me in video, which is pretty much the same thing. But I hope you're all doing well. Hope you all enjoyed your break. Glad to be back. We have a few things to cover today in AP Calculus. First of all, I just want to let you know of a couple of announcements before we get too into it. We have one more unit, or one more little topic we're going to talk about in these last 3 weeks. And we're going to have a final in the class, which will be, again, multiple choice, a multiple choice section, and a free response section. And the final will be about what we talk about in these last few weeks. It's about derivatives, and we're going to talk about some derivative rules, and we're going to try to make your life a little bit better in calculus, a little bit easier to do these derivatives. So we're going to talk today about section 2.2, chapter 2.2, basic derivative rules, and derivative rules. And these will be some rules you can follow for the rest of your time in AP Calculus. These are going to be critical to understand. So I want to make sure you get this video, take notes on this, write this down. You'll have a homework assignment after this to practice some of these derivatives, and I guarantee they'll make your life easier. So for a start, let's review what we remember about derivative, right? The derivative, f prime of x, right, was equal to, we said it was f of x plus h minus f of x over h, and the limit as h approaches 0. This was the definition of a derivative, right? Derivative. And we've done this process for a lot of equations. And we've done the process, we've simplified the derivative with the limits, and we've simplified and found a derivative. But hopefully, there's an easier way. And there is. If you remember, when we had a bunch of functions on the little graphing practice that we did the last day of before break, and hopefully you worked on that assignment over the break, that quiz, we talked about, you saw some functions and some derivatives, and hopefully you noticed a little bit of a pattern, right? If you had a linear equation as your function, the derivative of a linear equation was a straight flat constant, right? So linear became a constant. The derivative of a linear equation was a constant. Every time you had a line as an equation, the derivative of that line was a straight flat line of a constant, right? So this was x, x or 2x or negative 3x or whatever, and a constant, this was c, some constant number. And then if you had, for example, a parabola for your function, parabola, which was x squared, when you did the derivative of that, you always got a line, which was x. So linear became a constant derivative, parabola became a linear derivative, and if we kept going in this pattern, we saw we had a cube function, x to the third power. The derivative of an x to the third power became an x to the second power parabola. And so we can kind of tell that there's maybe like some kind of pattern going on, right? Linear becomes constant, squared becomes linear, cube becomes squared. We're always reducing the exponent by 1. And that's one of the basic derivative rules we're going to talk about, these patterns of how we can sort of identify these rules and use them to find derivatives easier. So basic derivative rules, there's going to be like 5 of them I think we're going to cover right now. 5 basic derivative rules, so you need to know each one. So here's the rules. Number 1, constant rule. First of all, let me just do a little bit of notation. We have f prime of x is the derivative, but what I'm going to be writing here is something, I'm going to use the notation d over dx. D over dx. If I do d dx, this is d dx. d dx. This means derivative. d dx is another way that we talk about a derivative. If I do d dx of f of x, that gets me f prime of x. That is taking the derivative of f of x. So d dx of f of x is taking the derivative of f of x, getting f prime, which is the derivative. So it's like a way to show that we're doing a derivative, d dx, the way we show we do a derivative. So first, constant rule. If your equation is a constant number, like f of x equals 2. If you do the derivative of 2, it equals 0. So the derivative of any constant is equal to 0. This is the constant rule. The derivative of any c of any constant will always be 0. So the derivative of 2 is 0. The derivative of 1/2 is 0. Even the derivative of pi is a constant. Derivative of pi is 0. Any derivative of any number without a variable, just a constant number, is going to be 0. That's our constant rule. So a constant is like just any number. Derivative of constants are always going to be 0. So that's rule number 1. Pretty easy. Here's some examples. Second rule. Constant rule. We have probably the most important rule, the rule you'll be using most frequently, called the power rule. The power rule is what we talked about with those exponents. So if I have, for example, some function, f of x, equal to x to some exponent n, okay? Could be x cubed, could be x to the third power, could be x to the ninth power, it doesn't matter. Any exponent, f of x equals x to any exponent, I'm going to if I do the derivative of that, d dx of x to the n, what I'm going to do is I'm going to bring the n down in front of the problem, bring the n down in front, make it n times, and then take my n and subtract 1. So bring the n, bring it down to the in front of the problem, bring the n down in front, bring n down in front, and subtract 1 from n, from the exponent. Subtract 1 from the exponent. And that is our power rule. Bring the n down in front, drop the n in front of the problem, and subtract 1 from the exponent. So some examples, if I have the derivative of x squared, right? That's going to be bring the 2, put it in front, bring the 2 down in front, make it x, 2 times x to the power of 2 minus 1 is 1. So the derivative of x squared is 2x. Oh my god, I could have been doing this the whole time? Yeah. Could have been doing this the whole time. X cubed, derivative of x cubed, 3x squared. Bring the 3 down in front, take the exponent, drop it by 1, make it x squared. Derivative of x to the 9th power, doesn't matter, make it 9, x to the 8th power. Bring the number in the exponent down in front, drop the exponent by 1, there you have your derivative. And this power rule is a powerful tool because you can have things that are interestingly different kinds of exponents. It works for any exponent, other exponents. It works for any exponent at all, So if I have, for example, the square root of x, in order to take the derivative of the square root of x, what would I do here? Well, the square root of x is the same thing as saying x to the 1/2 power. Right? Square roots are fraction exponents. So if I do the derivative of the square root, I'm going to do the same thing. I'm going to make it 1/2 x to the power of, let's see, 1/2 minus 1 is negative 1/2. So this is 1/2 x to the negative 1/2 power. Well, I don't really like negative exponents. Remember what we do with negative exponents? If an exponent is negative, we move it to the bottom of a fraction. So this becomes 1/2 x to the 1/2 power, or 1/2 root x. And if you remember, when we did this the long way, we started with this, square root of x, and we got 1/2 root x. And this is why. Because of our power rule, we take the 1/2 power, bring it to the front, take the 1/2 exponent, subtract 1, and get negative 1/2. Negative 1/2, negative exponent, belongs on the bottom of a fraction. And the 1/2 exponent becomes a square root. So this power rule works for any exponent at all. What if it was something like this? What if I wanted the derivative of 1/x squared? What do I do then? 1/x squared, how do I do that? Well, it's got an exponent, right? 1/x squared. I'm going to make this into the same thing. I'm going to say d dx of x to the, well, if it's on the bottom, that means my exponent is really -2. So I move my exponent up on top, and now I can do my power rule. Take the -2, put it in front, and subtract 1 from my x. X to the power of -2 minus 1, -2 minus 1 more, is going to give me -3. So this becomes -2/x cubed. That would be the derivative of 1/x squared. -2/x cubed. By taking my exponent, putting it up on top, making it a negative exponent, and doing my power rule. Bring the -2 in front and subtracting 1 from my exponent. It works with any exponent. The power rule works with any exponent at all. Even complicated ones like more complicated fractions. If I wanted to do the derivative, for example, of x to the 2/3 power, which is the same thing as saying the cube root of x squared. That's the same thing. Right? The 3 on the bottom, 3 on the bottom is the 3 in the radical, and the squared on the top of the fraction is the square root of the x. Becomes a fraction, right? Because in the square root, there's really an invisible 2. Invisible 2 right there. And a 1 right there. So it becomes a 1/2. That's why it's a 1/2. In the 2/3 power, same thing. You have your 2 as the exponent, your 3 is the bottom there. So let's say I want the derivative of this. Same rule. It's 2/3, bring the 2/3 in front, times x to the power of, let's see, 2/3 minus 1 is -1/3. So it's -1/3 is my exponent. We don't like negative exponents though, so we're going to make it 2/3x to the 1/3, which I can write as 2/3 times the cube root of x. That would be our derivative. Okay? So this power rule you can use in any kind of situation with exponents, right? Really, really convenient. Really, really easy. Lets you work it out. What if I had no exponent? What if I wanted to do d dx of x? X squared became 2x. X cubed is 3x squared. What's the power of x? Well, this is a power of 1, right? So I'm going to have 1 times x to the power of, well, 1 minus 1 is 0. And so the derivative of x by itself is just a 1. Derivative of x is just a 1. It's the number in front. Okay? So we can find derivatives using this power rule. Very convenient, very useful rule. Any exponent at all. Positive, negative, fractions, doesn't matter. The power rule is the same for all of them. So that's number 2. Third rule. Constant multiples. let's say, for example, that I have a number in front of my my variable. Let's say I want to know, let's say f of x is 3x squared. And I want to find the derivative of that. Well, d dx of any constant times f of x, right? Let me do this in a bigger bracket. Any constant times f of x. If I have a constant, some number c, right? That's like the 3 here, times some function f of x. Here's my x part, right? The 3 in front. I can basically factor out the 3. It becomes c times f prime of x. I just factor out the c. Factor out the constant. So the constant multiple rule is if you have a number in front, you just kind of put it in front. So d dx of 3x squared is going to be 3 times, well, I do the derivative of the squared part. I bring the 2 down in front. There's a 3 already there, so 2 times 3, that's going to become 6x. That's your constant rule, 6x, right? No matter what number's in front, I'm going to multiply by that number there. What if I had the derivative of, let's say, 2 over x? What do I do here? Well, this 2 on the top is like a fraction, is like a constant. I can factor it out. I'm going to be 2 times x to the negative 1. Right? This x on the bottom has an exponent of 1. Bring that x to the top, negative 1, right? Do the derivative of that. Bring the negative 1 down front. So it's going to become negative 2. X to the, bring the, subtract 1 from my exponent. Negative 1 minus 1 is negative 2. So it becomes negative 2 over x squared. Right? Took my fraction rule. I made my variable into a negative exponent. Used the power rule, brought the exponent down in front, multiplied by the number that was already there. Negative 1 times 2 is negative 2. Subtracted 1 from my exponent, got negative 2. Made that negative into a bottom exponent, negative 2 over x squared. Right? Works for anything. If you have a constant in front. What about taking the derivative of 3 radical x? All right, well, this is going to be the same thing as the derivative of 3x to the 1/2 power. So bring the 1/2 down in front. I'm going to have 3 times 1/2. 3 times 1/2, right? Do my power rule. 3 times 1/2, that's going to become, well, 3/2. That's fine. X to the 1/2 minus 1 is negative 1/2. So it becomes 3 over 2 root x. See that 3 on the top of the fraction? That 3 kind of stayed around. That's where it's from. Right here, right? That 3 on the top of the fraction, the 1/2 from the 1/2 power, and it becomes negative 1/2 on the bottom. So constant rules like this, right, let you do all kinds of easy manipulation using the power rule. One last one. What if I have something that looks scary, like 4x squared over 5? A derivative of this. Well, take that 4 over 5. That's the fraction part. d dx of, let me do it this way. Take that 4 over 5, this fraction part, that's your constant. That 4/5 is one whole constant fraction. And I'm doing the derivative then of x squared. Bring the 2 in front. That becomes, well, 2 times 4 over 5. The 2 is the top of the fraction. It becomes 8 over 5. X to the first power, right? 2 minus 1. Take my 2, bring it in front. 2 times 4 over 5. 2 times 4 is 8. 8 over 5. 2 minus 1 is 1. There's your derivative. 8/5 x. 8 over 5x. Just following those simple power rules make it all nice and easy. So you're going to have some practice with those. No matter what the situation, work it out so that you have the variable part as an exponent. Bring that exponent in front and do the power rule. Follow those simple rules. So that's number 3, constant multiples. If there's a number in front, just take that number and put it out front. Multiply by whatever you need to, that number becomes a constant. Okay? What was that, rule number 3? Rule number 4. Next rule is sum and difference rule. Sum and difference rule. The sum and difference rule, I mean, it's pretty obvious. Sum and difference rule. It's kind of obvious. It says if you have a function, f of x, plus some other function, g of x, and you do the derivative of those two functions added together, all you do is take the derivative of them one at a time. Of f and the derivative of g. That's your sum and difference rule. Basically, you are distributing the derivative. Distribute the derivative. You're doing the derivative of each part. Do each derivative independently. So if you have some kind of polynomial equation, for example, if f of x is, let's say, 2x squared minus 3x plus 5. I want to find d dx, right? I want to do the derivative of this. Well, I'm going to do the derivative of the first part. I'm going to do the derivative of this part by itself. Then I'm going to do the derivative of this part by itself. Then I'm going to do the derivative of this part by itself. Right, so I'm doing the derivative. I'm doing each derivative independently. So the derivative of 2x squared, I do my power rule. There's the 2, bring it down in front. 2 times 2, that's going to be 4. X to the first power, right? The 2 exponent drops by 1. 2 minus 1 is 1. Bring the 2 down in front, so 2 times 2 is 4. 4x to the first power, that's my first part. Minus 3 times x, well, the derivative of this, 3x, well, the x has an exponent of 1. So I bring the 1 down in front. 1 times 3 is 3, and the x goes away. So when I have an x by itself, it basically disappears, and I just have negative 3. Right? Negative 3 times 1 is negative 3. X to the 0 power goes away, so the derivative of negative 3x is just negative 3. Right? Bring the exponent down by 1. This x has no exponent, so it just disappears. And the derivative of 5. What do I do with the derivative of 5? Is it plus 5? What's the derivative of 5? No, derivative of 5 is a constant. So that derivative goes away. Becomes a plus 0. It's not even there. Right? The derivative of a constant disappears. It's a 0. So my derivative is 4x minus 3. Did the derivative of the first part, did the derivative of the second part, put them all together, I get 4x minus 3. So you just do the derivatives of each piece as you're going through. Okay. What about something a little bit more complicated? Let's see, can I zoom out here? Let's go back over here. Let's have another section. So these rules, let's take an example. What if I want to find f prime of f of x equals, let's say, negative x to the 4th power over 2 plus 3x cubed minus 2x. What's the derivative of this? I do d dx for the whole thing, I do the derivative, and I do each part independently. So the derivative of negative x to the fourth over 2. Well, I'm going to have a constant here. I have a constant of 1/2. So I'm going to take that negative 1/2, put that in front, right? Negative 1/2. I imagine that negative 1/2 is my constant part. Take that out. X to the fourth power, I follow my power rule. Take the 4, multiply it by the beginning, and bring it down by 1. So this is going to become negative 4 over 2 x to the third power. Right, I brought my exponent down by 1. 4 become a 3. The negative 1/2 was my constant part, this negative 1/2. I multiplied that by 4. I got negative 4 over 2, which is really negative 2. We'll simplify. And x to the third power. Plus, next part here, bring the 3 in front. 3 times 3 is 9. Bring the exponent down by 1, x squared. There's your exponent. Same thing here, negative 2x. Well, we learned that when you have an x by itself, it goes away. And the negative 2 stays, so it's going to be minus 2. So my answer, negative 2x cubed plus 9x squared minus 2. There's your derivative. All right, following these chain rules, the power rules, using the constant in front, figuring out how to do all these complicated looking exponents. Okay. I would ask if there's any questions, but you're watching a video. We got one more rule, one more thing to take care of, right? Let me just make sure none of your questions are too complicated here. Am I missing anything? You'll be fine. You'll be fine. All right. What if let me do one more example. What if I gave you something like find f prime of f of x equals something like this. X cubed minus 3x squared plus 7 over x squared. What do you do here? It's a complicated looking fractional problem. If we tried to do this the long way, oh man, we would be toast. Thankfully, we have all these rules. We have all these rules we can follow, and we can use those rules to simplify this problem and turn it into something we can do very easily. I have a bunch of stuff on the top divided by one x piece on the bottom. What I'm going to do, what I would like to do, is make each individual piece separate. So I'm going to take this x over 2 and give it to each of these as a fraction. I'm going to make this x cubed over x squared minus 3x squared over x squared plus 7 over x squared. And now I have individual pieces that I can simplify. X cubed over x squared, those two cancel with that one, becomes just x. Here, x squared and x squared cancels, becomes minus 3. And here, well, I have to deal with this. This is plus 7. I'm going to make the x squared, though, into a negative exponent. And now I can find the derivative of this, d dx, this whole thing, and each individual part I can do. Each individual part I can do on its own. The derivative of x, well, it's got a first power, bring the 1 down in front. It's a 1 in front of here, so it's just going to be 1. Derivative of x is 1. The derivative of negative 3, no, the derivative of constant goes away. This becomes a 0. So that's gone. And 7x to the negative second power, I bring my negative 2 in front, make it minus 14 x to the negative third power. So it's 1 minus 14 over x cubed. That is your derivative. That is f prime. right? To see how like simple rules like that can help us reduce a complicated looking problem into something that's pretty easy. Take this complicated problem, break it into its pieces, find the components, use the exponent rule, and break it down into its derivative. Much easier than using that derivative rule, the definition. So, we have those rules. We can work that out. One more rule to know about, and it's involving some trigonometry. So it's involving sine and cosine. So rule number, what is this, 6? What did I say? Rule number 3, rule number 4, rule number 5. I said 5, right? Rule number 5, our last rule, involves the derivative of sine and cosine. There are a lot of particular derivatives that you will need to know. And I'm going to post in the Schoology page a handout that lists all the derivatives of lots of different specialty derivatives. Mr. Mitchell, will I need to memorize this list? Yes, you will. You will need to know what the derivative of sine and cosine are, tangent, cotangent, secant, cosecant, all of these things, ln, so many particular derivatives. The more that you are able to memorize those, the easier your life is going to be. So for the derivative of sine and cosine, the derivative of the sine of x is the cosine of x. Not too scary, right? There's number 1. The derivative of the sine is the cosine. So, every time you have a derivative of sine, you'll get cosine. And, similarly, the derivative of the cosine of x, is, well, not so nice, negative sine of x. Negative sine. So the cosine becomes a negative. The derivative of cosine becomes negative sine. And the way you're going to memorize this is that the derivative of things start with a c will become negative. Cotangent, cosecant, cosine, all of the c derivatives become negative. Sine is easy. Sine is everyone's friend. Cosine's a little bit shady. Cosine becomes a negative. So the derivative of sine is cosine. The derivative of cosine is negative sine. So for example, find f prime of x of, let's do this one. If f of x is 2 sine x plus 3x squared. 2 sine x plus 3x squared. What is the derivative of that? Well, let's do d dx of the whole thing. For sine, I have this constant in front. The same rule applies. 2 is just going to exist in the front of my answer. I bring the 2 out. I factor the 2 out. It stays as part of my answer. 2 times the derivative of sine. We saw that derivative of sine was cosine. So it becomes 2 cosine of x. Just that, right? The sine x changes to cosine. Derivative of sine is a cosine. The 2 is a constant, it stays in front. Plus, now my 3x squared, I use my power rule. My 2 multiplies by the 3, becomes a 6. And my exponent reduces by 1. Power of 2 becomes a power of 1, so it's 6x. And this is my derivative. 2 cosine x plus 6x. Okay? So this is how we're going to find derivatives using these rules from now on. Power rule, your cosine and sine rule. Definitely memorize these. Derivative of sine is cosine, derivative of cosine is negative sine. We got our power rule, our constant rule, our sum and difference rule. And a constant multiple rule, right? Multiply the outside part. Just factor out the constant, bring it in front. So using these rules, you're going to practice taking some derivatives. Okay? In your textbook, it's section 2.2. Your homework is 2.2, page 118. I'd like you to do numbers, practice this derivatives, I'd like you to do numbers 7 through, what's a good one? 7 to 25, odd. And I'd like you to try 31 to 40, no, you know what, to 54. (41) to 54, 53, odd. Try those as well. All right, everybody, that's your assignment. You have some time in class. If you're done watching the video, practice this right now. You know what? Let me do one more thing. I need to give you some more examples. All right. We have time. All right, so here's what we're going to do. Your homework is here. Oh, what did I say, 41? No. Not 41, everyone. Not 41. I want you to do 31 to 53 odd. So let me do a couple of these examples with you. Particularly, I want to do numbers, some of the ones like number 31. We'll do 31 for you together, okay? Remember, what we are doing when finding derivatives, a derivative is simply a slope, right? The derivative is the slope of the tangent line. So this function that we're finding, these equations that we're finding, tell us the slopes of these lines. So if I wanted to, for example, find the slope of the tangent line at a certain point. If I said my function, this is number 31, my function was f of x is 8 over x squared. I want to find the slope of the tangent line at the point 2, 2. Find the slope of the tangent line at 2, 2. Now that we know these rules, we're going to put them into practice, right? The function 8 over x squared looks something like this and like this. At 2, 2, there's a point right here, 2, 2. I want to find the tangent line, the slope of this tangent line right there. M equals what? That's what we're looking for. And so I know that the slope equals the derivative. So I'm going to find the derivative of x, of my function, derivative of f(x), and I'm going to use that derivative to find the slope. So I know f prime, I'm going to do the derivative, d dx, of this whole thing. And this becomes, well, I need to use my power rule, right? I have my fraction on the bottom, my x squared on the bottom, becomes 8x to the negative second power, right? 8x to the negative second power. So I bring my power rule now. Negative 2 times 8 is going to be negative 16x negative third power. So it's negative 16 over x cubed. And that's my derivative. That's f prime. So to find the slope, I would plug in find the slope at 2, 2, you plug in x. Plug in this 2 into the x value there, and you would find the slope at that point. You would find f prime of 2, which is negative 16 over 2 cubed. It's going to be negative 16 over 8. It's going to be negative 2. That is the tangent slope m of this tangent line right here, negative 2. That's the slope of the tangent line at that particular value. Right? We're looking for the derivative at the value of 2. So we're looking for the slope at that particular x value of 2. So I plug in the 2, I get the slope. Find the derivative, plug in the point to the derivative function, f prime of 2, plug in the 2, get my slope. That's the slope of this equation here. What if I wanted to find the equation of the line? Could I do that? Yeah. Equation. I want to find equation. I want to find y equals mx plus b, right? Well, I have my m is negative 2, so I'm going to have y equals negative 2x plus b, and then I plug in my x and y. I know that x is 2 and y is 2, so I'm going to take those and plug them in to the x and y here to find the b. 2 equals negative 2 times 2 plus b. So it's negative 4. 2 equals negative 4 plus b. Add the 4 to both sides. b is 6. So my equation is y equals negative 2x plus 6. That is the equation of the tangent line. I could just say y minus y1. Well, anyway, I don't want to confuse you anymore. So I can find the equation of my tangent line. I can find my tangent slope. We can use all this, do all this, now that we have a much easier way of finding a derivative. We can do all this with a much easier method of finding a derivative. So that's your assignment. That was number 31. Find the slopes. Practice your derivative rules. When I come back, I will see you all on Thursday. I'll see you all on Thursday. Your homework is due that day. Send me a message if you have any questions. Watch this video again. Hopefully it helped. I'll see you all next time. Thanks very much.